Welcome to the third video of Module 6. In the previous video, we had discussed about security implementations in SAN. Now in this video, I'm discussing security implementations in NAS, which is Network Attached Storage. It's an important KTU question. So, the network is always open to different threats, viruses, worms, etc. Okay, so main security mechanisms are three here: permissions and ACLs, that is access control list. Okay, and the next is authentication and authorization mechanisms, that is using Kerberos, which is a network authentication protocol. Then firewalls are there. Okay, so going into details. First one, permission and ACLs. So we'll be discussing how NAS file sharing is done in Windows ACL as well as Unix ACL. Okay, in Windows it supports two types of ACLs, that is DACL, discretionary access control list. Okay, and the system access control list. Okay, and the first one is the normal ACL. Okay, and the second one, it determines what accesses are to be audited if an auditing is being enabled. Now there is object ownership supported by Windows, and that is the owner of an object has hard-coded rights to that object, which is not explicitly granted in SACL. Okay, then there is a concept of security identifiers, SIDs. ACLs are applied to directory objects known as security identifiers. Okay, they are automatically generated for the Windows server or domain when a user or group is created. Okay, and these are abstracted from the user. Now in case of Unix permissions, in Unix a user is an abstraction, that is a logical identity for any kind of ownership and the privilege of the operation. Okay, so the user can be a person or a system operation. Okay, and here too there will be user IDs and the user name regardless of whether it is a person or system or device. And the user can be one or more groups, and mainly the Unix permissions specify what can be done to a file and by who. So the common permissions are given are read, write or execute. Okay, written as R, W or E. E or X. X is the one for execute. Okay, so every file and directory, that is folder, will have three kinds of ownership relationships here, that is for the file owner, for the group the user belongs, and for all other users. Okay, so these are the three ownership relations. Okay, so there will be three access permissions, as I said before, that is the read access, that is one bit is represented by that, second bit for write access W, and for execute X. So, and the ownership relations will be owner, group and all. Okay, it's a triplet. So it's like when it's displayed, a set bit will be marked by its corresponding operational letter, whether read, write or execute, and a clear bit will be denoted by a dash, and you put them all together, it will be represented like this. Next is authentication and authorization. In a file sharing environment, NAS uses standard file sharing protocols like NFS and CIFS. So that is the network file sharing as well as common internet file sharing. Okay, now of course authentication and authorization has to be implemented in Unix or Windows. Okay, authentication requires of course verifying the identity of the network, looking into the credential in the network information system in a Unix environment. Okay, and in a Windows environment, the Windows client is authenticated by the Windows domain controller. okay, and it will be having an active directory, and the directory uses LDAP, which is lightweight directory access protocol, to access information about the network objects in the directory, and it uses a protocol, network authentication protocol, Kerberos, okay, for security of the network. That is in the case of Windows. Then NAS devices uses authentication techniques, the same authentication techniques to validate network user credentials. Okay, you have a figure to explain it. Okay, now, okay, although NAS devices supports both the methodologies for Unix and Windows, complexities arise when Unix and Windows users share the same data. So that figure is shown here. It should be properly maintained actually. Okay, when there is a mix of OSs, now a Unix client, Windows client, okay, and you have the NIS server, Unix authentication, Windows authentication, Windows having the Active Directory, and this is the NAS device. Okay, so the authorization will have the Unix object as such, and Windows object, that is the ACLs, having the identifier, okay, as well as the privilege. Okay, so these validate permissions with NIS or the domain controller. That is for Unix, and this is for Windows. Next, about Kerberos, coming under the second point. Okay, Kerberos, which is a network authentication protocol. Okay, it uses strong authentication for both client and servers using secret key cryptography, and it uses a mechanism of tickets actually. Okay, a client can prove its identity across an insecure network, okay, using this Kerberos. Okay, so just go through it. It's quite simple, and mainly there will be a Kerberos client and a Kerberos server, or KDC, that is the key distribution center. Okay, and the KDC implements authentication service AS and the ticket granting service TGS, and it has a copy of every password associated with every principal. Okay, and so it is absolutely vital for the KDC to remain secure. Okay, that is the server actually. Now, what is principal is that users and servers for which a secret key is stored in the KDC database are called the principals. Okay, in principals are nothing but users and servers whose secret key is stored in the KDC. So how is the process done? It has the following steps. You can easily follow it from the figure, and the explanation is given. Okay, so you can see you have a Windows client, then a KDC, and it's accessing an active directory, then the NAS device having a key tab file. Okay, so it starts in this way, the client requesting the ID proof, and the second step, the ticket granting ticket is given from the KDC. Let's follow it down here. So the first one, the user logs on to the workstation in the Active Directory domain or forest using an ID and password. So this is it. The ID proof is given, and the client sends a request to the authentication server, which is running on the KDC. Okay, and the second one, KDC responds with the encrypted ticket granting ticket, as you can see. Okay, and it has an encrypted session key, limited validity period. Okay, just go through. Then when the client requests a service from the server, it sends a request consisting of the previously generated TGT, which is encrypted with the session key, and the resource information. So you can see TGT plus the session key information it's giving on to the server, that is a KDC, which checks the permissions with the Active Directory. As you can see, the fourth one checking with the Active Directory, and the KDC returns a service ticket to the client. Okay, see, number 5 is the return of the service ticket. Then the client sends the service ticket to the server that has the required resources. As you can see, the ticket is sent to the NAS device which has the required resources. Okay, and the server, in this case the NAS device, will decrypt the server portion of the ticket and store the information in the key tab file. This is the key tab file. Okay, as long as the Kerberos ticket is valid, this authorization process does not need to be repeated. And the last step, the client server session is established, and the server will return a session ID to the client, which tracks the client activity. Okay, you can see the last step. This session ID is given from the NAS device to the client. Okay, so that is the second one. Now it is using a security implementation using the firewalls. So you can see it is in a demilitarized zone, DMZ. It's application server having firewalls on either sides when it is accessing networks. Okay, so the network layer firewalls are implemented in NAS environments to protect the NAS device from the security threats. Okay, the packets that are not authorized by a security rule are dropped. That's the rule to be followed. Okay, and DMZ means DMZ is something that provides a means to secure internal assets while allowing internet-based access to various resources, and this is possible by providing security through the firewalls. Okay, so the servers that need to be accessed through the internet are placed between a set of firewalls. Okay, the example is given, just go through it. So this is the conclusion to this video. Next would be the implementations in IP SAN. Thank you.